RET670 transformer differential protection. Yes, okay. So this is the file. We have 5 CT core, 1 HV, 4 LV. So the HV, so HV rating 1200 bar 5 and LV rating 5000 bar 5. This is the rating of CT from HV and LV. You check this all function block and production also. The production, so differential protection. Right now we give the setting 110 kV, 13.8 kV full load current, HV, LV and star to delta 5 zero sequence factor on, off, full load current, and check other settings also. This is protection on and high set slope 40% first slope, second slope 80%. This unrestrained actually 9 setting I change for testing purpose 2. I will return it. Harmonics 15 Hz and 25 Hz. These all are the settings. So now we'll go through one by one function. Now go the application configuration. Check. This is the function block of differential. So function block of differential, there is 5 CT connections. The first one HV connection, second there is single winding for HV, so second we make it off, and third, fourth, fifth, sixth, these all are current source. Third is the generator, fourth also generator, other two from the switch gear. So now go here. This is the current input source. The winding 28. First winding this HV current source. HV current source. All and LV current source. This is the LV current source. Another one LV2 current source. This LV2 current source. Same differential block. And input output winding 1, winding 2 and winding 3. This is the binary input slot. Binary input all are spare. This slot is spare. Then binary output slot. This is the binary output. Next this LED inputs. Okay, so this is the configuration, and we'll go to settings. Setting parameter, other all put the data. Like this winding 1, winding 2, winding 3. Okay, this is the differential function block settings. We connected Omicron double source current. This is the HV lead, and this one LV lead. This is the input input to Omicron, but output of the relay. Now check. This is the test report. This test report already I updated all the value according to this calculation also. So you check this all. Measurement we already verified. HV and LV1, LV2, LV3, this is the calculation for resistant current calculation. You check winding 1. This is the winding 1 pickup and dropout calculation and timing for HV, that one. This is winding 2 LV pickup and dropout calculation and timing pickup and dropout, single phase, 3 phase. Same winding 3, same winding 4, same winding 5, because totally 5 winding. Now we'll go to unresistant. This is the calculation for HV. According to this, I put unresistant value 2. Our setting is 9, but I put a 2 for testing purpose. We change that value. And another then come here. This is from LV side. LV1, LV2, LV3, LV4, like LV5. Then second harmonics. This is the second harmonics and fifth harmonics. Then slope 1 HV to LV 40% and 80%. And when we'll check the second slope, the current ranging more than 15 ampere, so that much current we can't inject for delta to star winding transformer. So I change my connection star to star. Here na vector group connection star to star. Then I injected a single phase only for 80% of slope. Other 40% slope I put delta to star and 3 phase injection, injected by 3 phase by Omicron. And same, this is the other winding, and this also next winding. Totally 5 winding, so that's why coming winding 1, winding 2, winding 3, winding 4, 5. This is the calculation method. This test report complete. I will show you 380 kV and generating transformer calculation. According to this calculation, you should follow the testing. If zero sequence factor on or off in the delta and star, the time what is the value we mention here also for single phase apply and 3 phase apply. This is the full load current. Secondary LV side, the full load current HV LV side, sorry, HV secondary. And differential calculation for single phase pickup with the star winding, zero sequence factor on condition. Same 3 phase. When 3 phase zero sequence on, it's not considered that value. And LV side, same LV side, I difference this setting, this FL is secondary full load current. This is zero sequence factor, the value 1.5 according to this secondary current. So single phase current, 3 phase current from LV side. Then this is our setting. Then slope test. So zero sequence filter on condition, this overall current, this is the formula. I differential slope intersection 1 2. According this, our setting and the slope 1.5. This is the assumed value. But I biased, we take intersection 1. Why we take 1.5? This is the more than the intersection 1 value. Intersection 1 value 1.25. Our value here 1.25. So we take more than this value 1.5 for slope checking. Then we make calculation. This is the value coming. Then you check here. And balance condition. When you make balance, then I bias 1.5, that is before I show you now here is 1.5 into full load. Full load means our already HV secondary current, so this value will come. And same LV side 1.5 into 7.32, this value will come. LV and HV, when you inject this and this for stable, this is the relay stable condition. When start to delta connection 3 phase, during injection in 3 phase it will be stable. If you are inject single phase, it's not stable. And this unbalanced condition, so you make same. And ID pickup means this value minus this. When you reduce the LV side of current, this current you inject stable will come. After you reduce, when you reach this value, it will be trip. Then go here. This, so we need to take two values, or the first value and the second value. When we get two value, then you make a slope verification. Example, this is the first value. Once you inject HV and LV, you take I differential, I bias. Then inject a second this value, I differential, I bias. Then you make slope section. This is the formula. Make calculate. Then you reach 80% of slope. Then 80% of slope. Say this formula. According this is the condition for stable HV and LV. This is the stable. Then you reduce from HV side until this, it will be tripped. Then same second value, make 3.5. First value 3.25, second value 3.5, and take this value. When it's coming, it will trip. After the trip, 1 second, I will show next. This is the harmonics. Actually that page missing. I will show to other value. Same. Once you get this value, then you put this 2 value, slope 2 value. When stripping it, then I differential, I bias, take this value. I differential, what is the value? I bias, what is the value? 2 value make. Then 80% slope will come, 0.81, 197, 273, this value will come. So this is the calculation to verify. And now you check relay physically. Okay, this is the RET670. Okay, lockout operated. This is the HVCT, LVCT1, LVCT2, LVCT3, LVCT4. So we injected relay terminal point, this one. Feedback we take at this point. This is the single line diagram.
सही है, पहले मार दें तो छोड़िए।
So now start 110 kV. According this calculation, this is the LV full load current, HV full load current secondary, LV full load current secondary, setting 0.3. So single phase pickup HV side and 3 phase pickup HV side. Single phase pickup LV side, 3 phase pickup LV side. First we will check pickup and drop out the relay. So now we start pickup and drop out for HV side, single phase pickup. This is the protection function block, and current as per the calculation 1.771, it is the pickup current. So I injected 1.7. I injected here. So now it's not operating, relay it's not operating. And from here this ball trip also not coming. I take feedback from Fraja here. This is the relay. Now check, I increase slowly through this space. our value 7.770. now I change it 0.01 0.002. I change here, then I increase slowly. Salam alaikum. I inject slowly. Yes, finish it, sir.
Can we send?
Go through the stability test. 3 phase I injected. System is stable. The differential current, bias current 1422, differential current 9, that means 0, near to 0. Relay not operated. Now I reduce from LV side slowly until our setting. This is the value 5.9, 11.9. I injected one series, it will be operated. I reduce. One second, change here, put it here. See, once 8.283. okay, it is operated. Differential operated. That time differential 1422, their bias differential 375. According this, so I bias, I differential, we take one value, same another value, to 6.848, then 9.4, that is a stable. 6.88 all here, and 13.77 we need injector, but maximum we have injected 15, so I injected 15. Now I injected, check, relay not operated, relay is the stable, this condition relay is stable. So now I reduce from LV until 9.4, it will be operated. Okay, now it's triple red coming, it is operated. See, coming. So 61659 and 540. I differentiate this one, bias this one, then according to this formula it is coming 40% of slope. Same we need to do second slope also. Second slope, as per our calculation, we need to inject 12.5 and 24 ampere. So this much we can't inject, so that's why I make a star to star in the relay configuration. Then I inject a single phase relay configuration. I make here star to star, then I will test this. So now I don't have time, I will